Betelgeuse, a luminous giant gracing the constellation Orion, has long captivated both seasoned astronomers and casual skywatchers. With its deep reddish tint and enormous size, the star is a celestial marvel, easily spotted by the naked eye from Earth. However, recent observations have brought Betelgeuse back into the scientific spotlight, not for its beauty, but for a shocking and dramatic increase in brightness, by an incredible 250%, detected by the James Webb Space Telescope. This extraordinary event has reignited discussions within the astrophysics community and raised urgent questions about Betelgeuse's current state and ultimate fate. Known as a red supergiant, Betelgeuse is in the terminal phase of its stellar journey. Located about 642 light-years away, it's among the most massive and radiant stars in our galaxy, with a diameter nearly 700 times larger than our Sun and a brightness more than 10,000 times as intense. Red supergiants are inherently volatile, prone to fluctuations in brightness as they near the end of their life cycles. However, even within the erratic nature of these stars, Betelgeuse's recent surge in luminosity is astonishing. It signals a possibly momentous event in the field of stellar evolution. Thanks to the James Webb Space Telescope's advanced infrared vision, scientists were able to cut through the thick dust and gas surrounding the star, gaining unprecedented insights into its surface and nearby space. What the telescope unveiled was breathtaking. The star's brightness had skyrocketed by 250% over just a few weeks, suggesting that something highly energetic and unusual was occurring deep within. The implications of this sudden change are profound. For many years, astronomers have speculated that Betelgeuse might one day explode in a supernova, a cataclysmic event marking the death of a massive star after it expends its nuclear fuel. While such an explosion was thought to be tens of thousands of years away, this new outburst of brightness has stirred speculation that the timeline could be much shorter than previously believed. The irregular activity seen from Betelgeuse in recent years, culminating in this extreme brightening, hints at a deepening instability. Such behavior could precede a spectacular end. If Betelgeuse were to detonate in a supernova, the event would be unprecedented in human history. The explosion would likely be visible even during the day and could outshine the full moon at night for weeks. Despite its potential for brilliance, Betelgeuse lies far enough from Earth to pose no risk to life. Instead, its demise would offer a once-in-a-generation opportunity for astronomers to study a nearby supernova as it unfolds, yielding valuable information about stellar death and the processes that govern it. The recent brightening also adds momentum to ongoing research into the mechanics of red supergiants. These celestial giants defy simple understanding due to their sheer scale and complex inner workings, often leading to unpredictable behavior. Betelgeuse has long been a puzzle, its light waxing and waning in irregular patterns. Unraveling the cause behind this dramatic 250% increase in luminosity could reveal essential truths about these dying stars. One possibility is that Betelgeuse experienced a vast convective upheaval, an enormous pocket of hot gas rising from its core toward the surface. Such convection is typical in stars of this kind and can cause significant spikes in brightness, especially if material is expelled violently into space. This ejected gas could expose hotter regions beneath the surface, making the star appear far brighter. Alternatively, scientists believe that Betelgeuse might have undergone a stellar eruption, shedding vast amounts of mass that formed a reflective cloud of gas and dust. This material, now illuminated by the star's radiation, could be amplifying its brightness. This idea aligns with what happened in late 2019 when Betelgeuse dimmed unexpectedly, a phenomenon many now attribute to a dust cloud partially blocking the star's light. The current brightening might be a recovery from that earlier dimming, with newly expelled matter reflecting additional light outward. Another theory focuses on Betelgeuse's magnetic field, a lesser understood aspect of its structure. Some researchers propose that the star's magnetic field is highly dynamic and may influence the flow of energy through its outer layers. Fluctuations in this field could trigger sudden changes in brightness. If that's the case, the current luminosity surge might be a direct result of magnetic disruptions within the star. Should this theory prove accurate, It would not only provide deeper insight into Betelgeuse, but also prompt new research into the magnetic nature of massive stars, an area that remains largely unexplored due to the complexity involved. As astronomers closely watch Betelgeuse, the issue of mass loss becomes increasingly central. Red supergiants are infamous for shedding large quantities of gas and dust into space, dramatically reshaping their outer structures and contributing to overall instability. If Betelgeuse is currently losing mass at an accelerated rate, it could be inching ever closer to a supernova. The timing of this phenomenon is significant. With the James Webb Space Telescope now fully operational, researchers have an ideal tool for probing the mysteries of stars like Betelgeuse. The JWST's instruments are capable of analyzing the light from stars in extraordinary detail, breaking it down to study temperature, composition, and internal dynamics, especially in dusty environments where traditional telescopes fall short. This advanced capability turns Betelgeuse into a kind of cosmic laboratory. Scientists now have a rare opportunity to observe, in real time, the dramatic final stages of a massive star's life. Still, caution is warranted. Despite the breathtaking rise in brightness, there's no certainty that a supernova is imminent. Red supergiants often experience turbulent episodes without ultimately exploding. Betelgeuse might simply be navigating another one of its many unstable phases, albeit one of the most intense ever documented. Nonetheless, the significance of this event is hard to overstate. A 250% increase in brightness over such a short time frame is rare and signals that powerful forces are at play inside the star. The celestial drama unfolding serves as a vivid illustration of just how dynamic the universe really is. Far from being still and predictable, space is teeming with activity, where stars evolve, decay, and sometimes meet explosive ends. One of the most exciting aspects of this situation is the potential for future discoveries. With Betelgeuse under constant surveillance by space-based observatories like JWST and ground-based telescopes across the globe, researchers are collecting a wealth of new data daily. Every flicker and flare is being recorded, creating a comprehensive record of the star's activity. Over the coming months and years, scientists will monitor the star's fluctuations, searching for more outbursts and analyzing any material expelled into space. These efforts may lead to breakthroughs not only regarding Betelgeuse, but also about the broader class of red supergiants. If humanity does witness Betelgeuse go supernova in our lifetime, it will be a defining event in modern astronomy, an awe-inspiring reminder of the life cycles that govern stars and galaxies. Betelgeuse, with its colossal size and volatile temperament, has always been a ticking time bomb in the sky. Whether this recent behavior marks a mere prelude or the onset of its final chapter, the world's eyes are now fixed firmly on it. The event has also emphasized the need for continuous observation. Global observatories, such as the Hubble Space Telescope, the Very Large Telescope in Chile, and several radio arrays, have joined forces in monitoring the star across various wavelengths. The JWST continues to lead this global effort with its unmatched sensitivity in the infrared range, unveiling details previously hidden from view. Through this monitoring, researchers hope to uncover the hidden mechanics of Betelgeuse's outer atmosphere. This region can serve as an early warning system for more dramatic shifts. By observing temperature changes, density shifts, and variations in the elements present, scientists can detect telltale signs of coming upheaval, like shock waves or mass expulsions. These observations feed directly into astrophysical models, many of which still struggle to accurately simulate the late stages of massive stars. With every new insight from Betelgeuse, theorists can refine their models, inching closer to predicting the timeline of a supernova. Current understanding suggests that when a star like Betelgeuse finishes burning its lighter elements, hydrogen and helium, it turns to fusing heavier ones in ever shorter phases. Eventually, this process reaches iron, at which point fusion no longer generates energy. The core then collapses, triggering a massive explosion that ejects the star's outer layers into space. At this moment, astronomers still cannot say with certainty whether Betelgeuse has reached the critical stage of fusing iron in its core, a point from which there is no return. In the life cycle of a massive star, this stage marks the final countdown. Once a star like Betelgeuse exhausts lighter fuels such as hydrogen and helium, it begins fusing progressively heavier elements: carbon, neon, oxygen, and silicon. This chain of nuclear reactions continues until iron is formed in the core. Unlike earlier stages, the fusion of iron does not produce energy. Instead, it drains energy, causing the star's internal equilibrium to collapse. At that point, gravity overwhelms the internal pressure, leading to a catastrophic core collapse and, ultimately, a supernova explosion. Although we cannot directly observe the core of Betelgeuse to confirm whether it has reached this terminal phase, certain surface behaviors and sudden fluctuations in brightness suggest that the star may be inching closer to this point. This possibility alone has become a focal point of scientific fascination across the globe. Telescopes both on Earth and in space are continuously monitoring Betelgeuse, not just out of curiosity, but because the potential implications of a nearby supernova are profound, both for science and our understanding of the universe. The detonation of a red supergiant like Betelgeuse would be an event of immense magnitude. While the explosion would pose no direct threat to life on Earth due to its distance, approximately 642 light-years away, the aftereffects would ripple across space and science. A supernova of this scale would release an enormous amount of energy, outshining entire galaxies for a short period. But more than that, it would scatter a rich array of elements forged within the star across the surrounding regions of space. These elements include carbon, oxygen, silicon, and iron, foundational ingredients for planets, atmospheres, and life itself. In fact, every atom of iron in your blood and calcium in your bones was forged in the heart of a long-dead star that exploded billions of years ago. Supernovae are not just cosmic finales. They are essential chapters in the ongoing story of creation. They sow the seeds of future stars, solar systems, and potentially new life. Therefore, if Betelgeuse were to go supernova, it would serve as both an extraordinary observational opportunity and a vivid reminder of our connection to the cosmos. Scientists would be able to study the explosion from start to finish, capturing valuable data on how massive stars die and how their remnants enrich the galaxy. Such a rare and close-up look could refine our models of stellar evolution and improve our understanding of the chemical pathways that lead to life-bearing worlds. Thus, Betelgeuse's fate is part of a grander cosmic narrative. It represents a chapter in the ongoing cycle of stellar birth and death, helping to shape galaxies and seed the building blocks of future solar systems. In watching this star, scientists are essentially witnessing creation in reverse, how the end of one star can contribute to the birth of many more. The unfolding story has also sparked public imagination. Betelgeuse has become a symbol of the living universe, a giant celestial body whose fiery fate may play out before our very eyes. Social media, science educators, and journalists have latched onto the drama, drawing millions into the unfolding mystery. The idea that a star visible from your backyard could erupt in a blaze that rivals the full moon is almost mythical. It evokes a sense of wonder not only at what we can see, but at the vastness of what we have yet to comprehend. Throughout history, humans have turned to the stars for inspiration and understanding. Today, in Betelgeuse, we find more than just a point of light. We see a living, breathing entity nearing the end of its existence, its legacy likely to shape the cosmos long after its light fades.